pumps are abundant. The scarce object is the verified handoff into a working building. The visible bottleneck was equipment cost and performance, especially whether a heat pump could work in ordinary homes. Heat pump equipment and policy support have expanded, shifting attention from whether the technology exists to whether homes can receive a correct installation at scale. A heat pump is not a drop-in appliance. Sizing, emitters, controls, insulation, commissioning, and homeowner operation interact. More equipment demand therefore creates a queue for scarce skilled labor. Rushed or weak installations reduce efficiency and trust, which then suppresses adoption. The IEA identifies installer shortages alongside cost and manufacturing barriers, while UK deployment statistics show that adoption remains an operational outcome rather than a simple equipment supply count. The evidence boundary matters. A behavioral and user journey study cannot by itself quantify the share attributable to installer capacity. Front cost, building insulation, electrical capacity, and consumer preference may co-bind or dominate installer scarcity. Training programs, simpler systems, and new build deployment could reduce labor intensity faster than expected. For European and UK residential hydronic retrofits through 2030, qualified installer capacity and installation quality increasingly bind delivered performance. Evaluate deployment plans by qualified labor, commissioning quality, and measured in-use performance rather than by units manufactured or subsidies announced. Once competent installation is abundant, grid connection, building retrofit capital, and seasonal electricity economics may bind next. A heat pump maps to a deployable software package. The installer maps to integration and operations. Commissioning failure maps to a production incident that makes nominal availability irrelevant.